Welcome to this section on image captioning with TensorFlow. Image captioning entails taking in as input this kind of image and then outputting metadata based on this input image. In this example, based on this image, we could generate the sentence, "A boy is studying inside a pool." Another sentence we could generate after looking at this image is, "A man studying his coursework inside a pool." Another one is, "A man studies underwater." From this example, it's clear that image captioning lies in the intersection between computer vision, which entails understanding these images, and natural language processing, which permits us to generate meaningful metadata from this image. The dataset we shall be using in solving this problem is the Flickr 30K dataset. Flickr is an image and video hosting platform, which is a community home to tens of billions of photos and 2 million groups. Let's now explore this Flickr 30K dataset via this link, brianplumer.com, Flickr 30K entity. The Flickr 30K ended this paper entitled "Collecting Region to Phrase Correspondences for Richer Image to Sequence Models" by Brian Plumer, Li Wei Wang, Christopher M. Cervantes, Juan Calcado, Julia Hokenmai, and Svetlana Lazebnik. The Flickr 30K dataset has become a standard benchmark for sentence-based image description. This paper presents Flickr 30K entities, which augments the 158K captions from Flickr 30K with 244K co-reference chains, linking mentions of the same entities across different captions for the same image and associating them with 276K manually annotated bounding boxes. As you could see in this example here, where we have a man with pierced ears is wearing glasses and an orange heart. So we see that the positions of the objects in the image have been located and then given a particular tag or particular color. So this person, you see a man, color red. We have the glasses purple. We have the earrings, the blue right here. And then this orange heart is in cyan. And then the Flickr 30K dataset is also defined or constructed such that for every image we have several captions. That is actually equals 5 captions. So for this image we have 5 captions, for this 5, and this 5. We have here a man with pierced ears is wearing glasses and an orange heart. A man with glasses is wearing a beer can crushed hat. A man with gauges and glasses is wearing a blitz hat. A man in an orange hat staring at something. A man wears an orange hat and glasses. Now let's visit the original Flickr 30K dataset site, which is this one right here. And there's a second link in the slides. Also note that the reason why we have up to 158,915 sourced captions is because for every image we have 5 captions. So if we take this and multiply by 5, you should get this. Now at the bottom of the page we have this form here. Fill the following form to request access to the Flickr 30K dataset. There we go. You just have to put in your name, email, institution, and that's it. They'll send you a link to download the dataset. After downloading the dataset, we'll have this token file right here, which will convert into a txt file by simply changing the extension from .token to .txt. Then also we have this images, the 30,000 images, which was described earlier, as you could see right here. And then for this first image, for example, its link with its token is quite easy. You see we have 36979, Control F, 36979. Let's find that. Let's get the exact image like based on this. So we go down and that's fine. So there we go. We arrived at this position where we have this exact image here. And let's look at this description. A group of friends playing cards and trying to bluff each other into making a terrible mistake. A group of college students gathers to play Texas Hold'em poker. Several men play cards while around a green table. A group of several men playing poker. 6 white males playing poker. So we see that this data set has a very great way of annotating this input images right here, because now instead of just working with just say 6 white males playing poker, we have all this 5 different captions which although describe the same scene but describe it from different perspectives. Let's now look at the code. We start by defining the path for the images and then the path for the text. So run this, and that's okay. Once this is done, we could now read through the text file. So we open up this text file in R+ mode using the UTF-8 encoding, and then we simply read lines. So we're going to read line by line. Let's run this and let's print out the lines. Print out lines. That's fine. Now note that this captions1.txt isn't the actual or the full captions file. That's why we could actually read this. So we're just shorten it so that we could be able to visualize it like this. So instead of about 150,000, you'll see that the length is quite small. See, we just have this number. Now let's get back to it and look at what it has to offer. Now here we have the image, the name of the image. We have this tab. Then we go to the first caption. So here we have the first caption: 2 performers, 1 man playing a guitar, and all of that. And then we have now the next line. We have again that same image, but now specifying that as the first caption or the second caption. If we suppose that this is the first, then there's the second. Next line, we have this second or third tab. We have the caption, next line, and so on and so forth. So basically we have this list which is made of the images and the different captions. Now for all these lines, we are going to extract the captions, and there we go. We split out these lines for, so for example, line I, let's take this. Let's say we have here 1. We could print out the split. Oh, we made an error right here. Let's take this off. So let's just take the first line and run this. That's fine. So now we're able to split out. So for each of the lines, so for this, know that this is one element of our list. This is another element. This is another element, and so on and so forth. So for each of these elements, we do the split based on the tab. That's why we have this image name, and then we have the caption. And then with this, we create a data dictionary which takes in this first part of the split, which is the image name. So our dictionary takes in the image name as key, and then as value it takes in the caption. Note that we take off the last 3 elements here. So the split one is actually the caption, but taking off the last 3 elements means basically we are saying we don't want this next line and then this full stop right here. Then apart from the data dictionary, we define this string captions which will contain all these words or all these sentences, and it's these captions which will be used in constructing the vocabulary. So that's why we see again we specify just this values, which are actually the captions, because we don't need the images in generating our vocabulary. So that's it. Once we're done with that, we just add this start token so that the start token could have a low position in a vocabulary. That's why we added say 3,000 times. You could increase the number of times we have the start token so that it could take in a reasonable position in our vocabulary. Nonetheless, we could do without this. So now let's run this captions. So that's it. You see that we start with the first. Basically, since we didn't do this many times, let's do this again. Let's run that. Take back, run again, run. Now you see that we have all those captions which are just joined together simply, and then at the end we have the start tokens, so that the start token occupies a reasonable position in our vocabulary, as we've seen already. Now our next step involves making use of TensorFlow's preprocessing.tx.tokenizer to create this tokenizer, which we shall fit on this captions right here. Recall that this captions is containing all the words in our data set. So we shall create a tokenizer which takes into consideration all the words in our data set, but also noting that we could specify the maximum number of tokens which we could take into consideration. So if we want, say, a 1000 sized vocabulary where we only have 1000 tokens, we'll specify the max token to be equals 1000. And if we want, say, 10,000, like in our case now, we'll specify the max token to be 10,000. So that's it. We have max token equals 10,000. Run that. It's fine. Okay, so we have that done. Now, as we've said, we have to fit this on our captions. So that's why we have this right here. Then we are applying the split because each word is separated by a space. Also note that in the tokenizer given by TensorFlow, it permits us to do some filtering such that this special characters right here aren't considered when building our tokenizer. So we could run this, and then let's come up with, see, we don't have this number of words in our vocabulary. So this is a 10th. This is the, we have this unknown right here, which matches up exactly with what we had defined here. So if we take this, for example, to say, let's put this as unknown. See, that's it. Anyway, let's get it back. Then also, if we want to select this 0th index, you see we have this error. Now note that this doesn't exist, but we shall be using the 0th index for our padding, as we've always done. Then here are some other constants. We define the input dimension of the images, the batch size, the model size. We'll see this later on for the transformer, the sequence length for the transformers, the number of layers, number of heads for transformers, and then this maximum token is repeated. So that's it. Go run that. After feeding our tokenizer on our data set, we will now have this where the start tokens index is 75. Let's keep this aside for now. We have the caption, which is this our data dictionary, which links this key, which happens to be the image file name, to a caption, which we shall pass into this caption variable right here. So here we have the file name, and then we include this ds3 to specify the caption we'll be working with, given that we have 5 different possibilities. That's going from ds0 to ds4. So we could have this up to ds4. Now once we have this caption, we could print this out. Let's print out the caption so we see what it looks like. Basically, it does it. 2 friends enjoy the time. Enjoy time spent together. We have this. 2 young guys with shaggy hair look at their hands while hanging out in the yard. Now, once we have the caption, the next thing to do is to use the same tokenizer and then convert this text into a vector where each word is linked to its corresponding index in the vocabulary. So that's why right here we have this caption, which is this, and then we'll do the split so that we have a list now made of each of these words. We'll pass each of these words into our tokenizer, and then we generate the sequence which has this linked, or which has this converted into the different IDs. So from this we could print out the caption sequence. We have that, so we'll see that 2 is the 51th position, young 20th position, and so on and so forth. To verify this, we could print out the tokenizer dot index to word. So that's it. Let's select, for example, 20. You see 20 gives us young, and see that it matches up with what we had here. So that's fine. We'll now have the sequence which we'll be needing. Then once we have this, what's left for us to do is to pad. And to do this padding, we'll simply use TensorFlow's sequence of pad sequence function or pad sequences function, which takes in the caption sequence. So here we have cap sequence. There's a maximum length, which is like our sequence length. Then the padding is post, that's done after this last index right here. And then we also have post truncating. Now the use of the padding, we know that already. In the case where our maximum length or this maximum length is greater than what we, or the number of words in our caption, then we just have to complete it with zeros. Now for the truncating, that's in the case where, suppose the maximum length in this case was just 2. If we have a maximum length of 2, then we'll be picking up only 2 of this. Now in the case where we have this truncating post, it means that we'll take the first 2 and then the rest are taken off. So let's print this out now. We have the cap token, run that, that's fine. So we see how the first 2 are taken. Now if we have the pre, see we take the last 2. Then if we have the padding, let's maintain the padding to be post, and then now we have 20 right here. So that's it. Now we see how we pad this post, and let's pad it now pad that pre. See, it starts from the beginning. So basically it does it. We'll get back to post for the padding and then post for truncating. Now obviously the reason why we have the start token is because we have 2 inputs and an output. Now the first input is the image, the second input is the right shifted output, and that's why we have the start token. So basically, instead of having, say, let's run this here, instead of having this, now we shall have to put in the start token and then right shift all this to the end. So with that, we'll see how right here we take the last elements. So basically we're taking this elements right up to this second to the last element right here, or rather we're taking the first elements. So we'll take this element right up to this element, and then we now pass in the start, which is the 75 to come before this. So let's take, for example, we had 51 4 5, suppose it was this. Let's add some zeros for padding. So we have this and that. Okay, so suppose we have this. Now what we're saying is this our new array becomes, so if we have A to be this, and then let's print out, let's print out A -1. You see that it gives us this elements right up to this one. And then if we have to do, let's take this to a constant, to a tensor. So we have this tensor right here, run that, and then come collect this concatenation. So you have to concatenate right here. Now if we have print of tf.concatenate, where we do, say, 75, let's have this. So this is like our start token. We concatenate this 75 now with A up to the second to the last element, and we close that. So we'll run this now. We omitted the axis, so let's take this. That's fine. Axis, the last axis -1. Okay, so we'll see how we managed to shift this while adding the start token before, and basically that's what we've done right here. Now once this is done, we can run this here, and we'll see that this is now our second input, and then this is our output. So coming to our data generator, we have the image, the byte size, the image list, tokenizer, data dictionary, the start token, the input dimension of the images. Then in this we call the data generation function, as we usually do. We have the ID, the first ID is passed, say 0. We go from 0 to 1 times the byte size. We load the image. And now what's interesting to note here is that instead of just having to append this image onto X, what we'll do is we take this image and actually do the adding onto X 5 times. And the reason why we do this is because one image represents 5 captions. So in our model, this will be seen as 5 different inputs with 5 different outputs. So that's why we repeat this, our inputs 5 times right here. Then for I in the range 5, we just repeat what we've seen. So we get the caption. Once we get the caption, we convert into sequence. Once we convert to sequence, we do the padding. Once we do the padding, we now have this our y1, which is our input of the shifted output. So there's it right here, and then this is the output itself. So basically we repeat this 5 times, so we have x, y1, y2, the same dimension. Then we convert it into tensors, and then we pass this in this dictionary. So that's it basically. Once we have our data generator, we define the training images folder, the start token, which we've done already, and then our train generator is ready. So we could run this, and run this.